Welcome to Unit 10, Lecture E. We're just going to basically talk about the contact process really quickly today. Contact process is the manufacturing of sulfuric acid. There's a couple of reasons that I want to show you this. Sulfuric acid being an extremely important industrial compound, and it's going to show you a little bit of kinetics and equilibrium ideas when we do this. So the first thing we do is we go back to our roasting of sulfur ores when we did our redox. So we're going to turn pure sulfur into sulfur dioxide. We're trying to get this sulfate polyatomic ion thing made. We're going to take that sulfur dioxide and oxidize it some more. So we're going to make sulfur trioxide. We're going to use a catalyst to do this. So the catalyst, again, is not used in the reaction. This helps the reaction to happen. Platinum or vanadium are extremely expensive metals. We can use this as a catalyst because it can be reused over and over again, which makes it feasible to use in a chemical application. Notice that heat is a product in both of these, so you would think that we would want to cool this using kinetics and equilibrium and Le Chatelier's principle to force this to the right, but collision theory says the higher the temperature, the more reactions we'll get in the first place. So this is where we find our optimal temperatures. So a medium temperature of 500 degrees Celsius will speed up both the forward and reverse reactions without slowing down the forward too much. And so they're going to heat this at high temperatures to get more collisions, but not too high so that the reverse goes faster. Then they're going to take that sulfur trioxide, and if you have SO3 and you add it to H2O, we should get H2SO4. The problem being that the sulfur trioxide is very slowly absorbed by water. So you would have to pump it in and keep it pressurized and wait for it to get absorbed in. Kind of the way that carbon dioxide makes carbonic acid in your soda. We would have the same thing, but that's way too slow of a process for industry. So what they do instead, and this is where it gets a little weird, sulfuric acid absorbs this sulfur trioxide quickly. So to make sulfuric acid, they start with sulfuric acid, add it in, and we get this weird in-between molecule, and then dilute it down with some more water. So for every 1 mole of sulfuric acid, we make 2 moles of sulfuric acid. So they can just drain half of it off, and once you get started in industry, they buy some sulfuric acid in the first place. It's going to replace itself. You double the amount you have, you pull off what you need to sell, and you have the rest left over. So this is just a quick application of some of our redox and our kinetics and equilibrium ideas into an industrial application. Don't be surprised if they use this for an example. And that wraps up our acid-base unit.